All right. Hey everyone. Today I'm going to be presenting a short poster on the long-term patterns of bird populations in a threatened grassland ecosystem. Our study was conducted in the Nannaj grasslands of Maharashtra from the years 2009 to 2020. The annual rainfall is quite low, 450 millimeters, and the temperature ranges from 16 degrees in the winter to 43 degrees in the summer. The landscape is home to a plethora of avian life alongside wolves, foxes, and black bucks. Let's dive right in the materials and methods. On field, 2 to 3 field observers went out every day, and a daily bird register was maintained containing all the list of commonly seen species. A species was ticked if it was seen or heard, and it was crossed if it wasn't. A species was not marked present until the identification was certain. For the land conversion estimates, we went around collecting expansive GIS data from the region. As you can see here, the Nannaj village is at the center, a 6 kilometer radius circle from there, and it also encompasses the Great Indian Bustard Sanctuary, which is a protected area. So for visualizing, what we did was we used appropriate R packages, Google Earth Pro, and the WorldClim dataset. We divided the year up into fortnights, and the proportion of days that you see it within the fortnight was used as a proxy for abundance. So in the first fortnight of January, the Eurasian marsh harrier was seen at proportion 1, which means it was seen at all 14 days that the survey was conducted. And similarly, in April, it was seen in none of the days. Our assumption is that if a bird is more abundant in the landscape, the more frequent it is that you see the bird, and the more likely you are to see it every day, right? But can we really trust the results that this kind of data can tell us? Was a question we had. For this, I did a preliminary check of the validity. I took 2 pairs of species that we thought were similar in life history and foraging behavior and dietary needs. These pairs were the gray strike and the bayback strike, along with the yellow wagtail and the gray wagtail. So our assumption here is that similar species in terms of life history, foraging behavior, and dietary patterns would be affected in similar ways by changes in the environment, be it land use change, be it temperature. We might not know what the parameter is, but the change would likely affect both of them in a similar way, is the assumption. What we saw was that the strikes were adding up, were coupling beautifully with each other, and the same was true with the wagtails over the years. Right, the plot that you see here has been each point is a grouped proportion of 3 years. This was to account for yearly variability that we saw, which would otherwise give us a very messy plot that we couldn't interpret very easily. So let's analyze some trends given that the data can be trusted to some extent. A sharp increase was seen in woodland and agricultural species, right? Species that were able to adapt to agricultural changes in the landscape. There was a sharp increase. Similarly, there was a bifurcation within the grassland species that were smaller and were able to adapt to these land use changes, such as the yellow-white-tailed lapwing and the ashy-crowned sparrowlark, did show an increase, whereas species that are more reliant on old world grasslands, such as the Great Indian Bustard and the red-necked falcon, showed steady declines from 2009 to 2020. Okay. As a correlation, we also decided to plot the land conversion that occurred within the landscape. Throughout the study period from 2009, in fact, from 2003 to 2020, we saw a steep increase in the amount of land utilized for other purposes and not left as grasslands. Most of these lands were outside protected areas, but were still grasslands used by the grassland species. As you can see here, unprotected grassland is being eaten up by agricultural land. Okay, now let's get to the curious case of the hoopoe. Now, in case of the hoopoe, consistent with previous studies that showed a subpopulation migrating while another subpopulation staying in the same landscape, as you can, with which Dr. Arleta was able to show in case of the European population. We saw a similar trend with the checklist data, where proportions plummeted towards the summer and increased sharply again nearer to the winters, right? Now, we might have to look into this a little more detail with our point count data that we started collecting. But a preliminary analysis does show this trend. We also see a sharp decline in the Eurasian marsh harriers abundance in the wintering seasons. As you can see, consistently throughout the years, it's been coming down. However, this trend is not seen for other raptors. We suspect it's because of the harrier's nature to prefer mainly natural grasslands, and they seem to be quite sensitive to land use changes as opposed to other raptors in the landscape. Let's get to some migration data analysis. We hypothesized that we would see a varying response in the migrants depending on the length of migration, and we would see a shortened stay of wintering times for long distance migrants. This was consistent with previous literature published by Dr. Gordo. So as you can see here, the yearly plots that we obtained by the fortnight method that we described earlier are quite messy, and you can't really see when they're coming in and going out. So what I essentially did is I took the last date of the maximum and the first date of 0 and plotted them to be these bar plots. Right, the black line represents the middle time of the species moving in or moving out of the landscape. The arrival is shown in red and the leaving is shown in blue. As you can see, there are years when the arrival is slower, when it's more rapid, and in some cases it's just within a fortnight. So this was the only trend that we were able to see, and there was no clear trend in the dates themselves, right? So this is all about the work that we've been doing over the past year. Let me just spend a minute to thank Sarang, who's been doing phenomenal work for collecting this data for 12 years. Dr. Suhel Quader, who allowed me to access this data and analyze it. Dr. Kavita Ishwaran at ISC, who was my ISC summer project mentor. Priti Bangal for offering assistance and comments throughout the entire process. Shikra Bhatt for helping me with the ggplot analysis, and most importantly, the Nature Conservation Foundation, who's been doing this work for close to a decade now. Thank you all for your time, and I look forward to your questions. Thank you.